Okay, this is day 8 of Advent of Code 2023. Again, recording in 2024. Okay, so we are now riding camel across a desert, and we spot a sandstorm quickly approaching. When you turn to warn the elf, she disappears before your eyes. To be fair, she has just finished warning you about the ghosts a few minutes ago. Probably got scared. One of the camel's pouches is labelled Maps. Sure enough, it's full of documents, your puzzle input, about how to navigate the desert. At least you're pretty sure that's what they are. One of the documents contains a list of left-right instructions, and the rest of the documents seem to be describing some kind of network of labelled nodes. Seems like you're meant to use the left-right instructions to navigate the network. Perhaps if you have the camel follow the same instructions, you can escape the haunted wasteland. After examining the maps for a bit, 2 nodes stick out. Or 3 A's, 3 Z's. Or Z's for you Americans. You feel like AAA is where you are now, and you have to follow it left-right until you get to triple Z. In this format defines each node of the network individually. For example, blah 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 blah. And I've popped the test input up here in my test. Starting with AAA, you need to look up the next element based on the next left-right instruction for your input. In this example, start with AA, A, and go right, choosing the right element of AAA, which is CCC. Then L means choose the left one. For CCC, we're going to then choose ZZZ. Followed by the left-right instructions, and we get to ZZZ in 2 steps. Of course, you might not find triple Z right away. If you run out of the left-right instructions, repeat the whole sequence and keep going. So RL actually means RL, blah, 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 so on. For example, here is a situation that takes 6 steps to reach triple Z. So in this particular one, we have LLR. So we're going to go LLR, LLR, LLR until we reach Z from A. Now, what I'm actually going to do is add this extra test input to my test. So if we just get rid of that and do import PyTest, and then we're going to do at pytest.mark.parameterize. I'm going to do the string, let's call it the text, and the expected. So let's move these out. So these are now going to be a list. We're then going to take all of this. Let's grab all of that. And yeah, I thought that was going to work. That's just going to pop it all in there, isn't it? Okay, let's grab it this way. And so now if we do it, pop it there, paste. I was one short. Right, so we want to go like this. We then want to say that this one has us reach it in 2 steps, and then we have another one here, and this will reach it in 6 steps. And if we just grab this, come over to here, paste it in there. So now we have these 2 test inputs here. Let's do text and expected, and then this way we can get rid of all of this, and we could just do set solve using the text is equal to expected, and so now we have two different tests for this particular one. Cool, so let's get going on this one. So ultimately what we need to do first is to split everything by well, we have these 2 sets of things. So we have our instructions, and then we have the, if you like, the map of where to go. So we'll get the map, the instructions first, and then the map afterwards. So if we firstly, so if we get the path and the instructions and the path, let's call it M for the map. Yeah. For the map, right? Cool. Is equal to string dot split, and we're going to split that by double new line. So then we have the map, which is all of this stuff, and these instructions at the top here. So then what we want to do is we'll keep the path, the instructions themselves separately, or separate, and we'll just work on the map for now. So let's call this variable a path map. So all I'm going to do is create a dictionary, and the key will be the source node, and then we're going to have the left right for which way it should go. So if we're going to go left, we're going to take the first entry. If we're going to go right, we're going to take the second entry. So let's just do for line in the m dot split lines. So that's going to be going over all of these parts. For each of those, we're then just going to do the key value is equal to line dot split. We're going to split that on the space equals space. So then finally, what we want to do is say the path map for the key is equal to the value, but we want to start from the first index and we want to go to the last, the one before the last, because we don't want these parentheses around it. And we're going to do dot split, and we're going to split it by the comma. So we're going to get rid of these, and then we're going to split it by the comma. So that's going to give us these two entries here. Cool. Cool. So now we just define the start, which is equal to A, the end, which is equal to the triple Z. Okay, so simplest way with this one, I think, is just doing a while loop. So while start does not equal end. For let's say the for I in instructions, total plus equals 1. If the instruction is to go left, then we are going to say that the start is equal to path map start 0. So what we can actually do here is, instead of if it's equal to this, we can use a Boolean representation. An integer representation of a Boolean. So we can say if it is right, we're going to go to the right, which is a 1. So instead of doing it this way, we could say start is equal to path map start int representation of the instruction is equal to right. Now will send us over to the right. If it's false, it's going to send us over to the left. We do want to also check within, as we're going through the instructions, if we're at the end already, because if we're at the end already, we want to just stop. So if start is equal to end, we're going to break. Otherwise, we're going to increment the steps, or the total. And that, I think, should be it, mostly. There we go. Okay. Key error AAA. For each of those, path map is equal to that. Key value. Is that not right? Okay, so we're getting an error here, path map start, key error AAA. Okay, so let's just print path map so the path map is here. One, hang on. Those don't seem right. That's because they're absolutely not, are they? Okay, let's grab this again. And let's just get rid of all of this. I think that's where we've gone wrong. Right. There we go. Right, so let's get rid of that print of the path map. Okay, so there we go. We've solved that one. So all we've done here is create a map of where to go from all of these things. So we've added AAA to the dictionary with a left and a right, B with a left and a right, so on and so forth. And then all we do is just go over each one and use that as the start position. We then get the left and the right for that particular one, and we just keep going over that until we get to the end. Yeah, that was a real simple one for day 8. I'm surprised it was as simple as it was. So that was part 1. So part 2. Let's firstly grab all of this and go to part 2. Pop it all in there. So for part 2, ultimately we're doing a lot of the same stuff. So that's why I've kind of copied all of this over here. So for part 2, Sandstorm is upon us, and we're not any closer to escaping the wasteland. You had the camel follow your instructions, but you've barely left the starting position. It's going to take significantly more steps to escape. What if the map isn't for people? What if the map is actually for ghosts? Are ghosts even bound by the laws of space-time? Only one way to find out. After examining the maps a bit longer, your attention is drawn to a curious fact. The number of nodes with the name ending with A is equal to the number of those ending with Z. If you were a ghost, you'd probably just start at every node that ends with an A, and follow all the paths in the same time until they all simultaneously end up at Z. So here there are 2 starting nodes. So this time we have this example. So let's firstly update the test. So we don't need multiple test cases in here now. So if we just get rid of these, so let's just do text is equal to this, and expected is equal to 6. So that'll be there. So you probably have already noticed such a large number here. Anyways, so 2 starting nodes, this one and this one, because they're both ending with A. As you follow each left and right instruction, use that instruction to simultaneously navigate away from both nodes that you're currently on. Repeat until all of the nodes you're currently on end with a Z. If some of the nodes don't end, if only some of them end with a Z, then act like the other nodes, then they act like any other node and you'll continue as normal. In this example, you would then proceed as follows. So you do this, you get to a Z here. You get to a Z here, you get to a Z here, you get to another one here, not there, and here we're finally on a Z for both of them. In this example, you end up on the entirety of nodes ending in Z after 6 steps. Simultaneously start at every node with A that ends with an A. How many steps does it take before you're on all nodes that end with a Z? Now, This one was a fun little challenge. So straight away, as you can tell with this huge number, what we don't want to be doing is iterating over all of them and doing all of the calculation, because you're just going to be here for hundreds of years waiting for it to finish. So what we actually need to do with this is find a loop. So each one is going to loop a certain amount of times. So if you have this one, for example, we're going to get to a Z at one point. If we have this one, it's going to get to a Z at a different point. At some point, they will sync up and get to all the Zs. So let's find out how we do that. So we have these, the test already set up. We've already got the instructions split out. We've got the each of the lines that we're going to be going over. So this time, instead of finding or setting the starts here, what we're going to do instead is set some start nodes. And this is going to be equal to a list. We are going to filter. Let's go with a little lambda x dot ends with, because it's a string, ends with an a. And we're going to give it the path map keys. And then finally we have the let's say the steps, and this will just be equal to a list to start with. So what we're going to do, we're going to go over each of the start nodes, and each of the starts that begin with an A, and we're going to get to a point where it ends in a Z, and we're then going to break out. We're going to save that count of how many steps it took, and then after we've got all of the steps, we're then going to go over the steps and find the lowest common multiplier, the LCM, and use that as the score, basically. We don't necessarily need, we don't need the start is equal to end anymore. We do not want, in fact, yeah, we can get rid of, let's say, all of that. Okay, so for n in start nodes, so let's say that the total for this particular one, let's call it a count, is equal to 0. The start node is equal to n. So we're going to keep updating this start node, but we want to keep track of n. I think we need to keep track of n as we go through it. Yeah. Sorry, we don't need to keep track of n. It's just that we're going over all of the n's here. So if we're changing it, it could cause a bit of a problem with the loop. But yeah, we could be okay. We could be not. Anyways, while not start node dot ends with z. So while we're not on one that ends with a z, not on the end, for the direction in the path, in the instructions, sorry. Yep. So we want to just double check again if the start node dot ends with a z, then we're going to break. Else we're going to do the count plus equals 1. And then we're going to do the whole start node update again like we did with the last one. So the start node is equal to the path map with the start node, and we're going to get the int representation of the d is equal to r. Cool. So while we're not on the end, we're going to keep doing that. And then finally, when we are at the end, we're going to do steps dot append t. Okay, so what we're then going to do, for this particular one, we actually want to start with a total of 1 because we don't want to multiply by 0 to start with. What we're going to do is we're then going to go over each of the amount of steps it took, and we're going to multiply, we're going to get the lowest common multiplier for all of them, but we need to start with 1 for the total. So the way we're going to do that is we're going to go for let's say s in steps. The total is then going to be equal to, and we're going to take the amount of steps multiplied by the total. So initially it's going to be 1 times the total. We're then going to divide, we'll get the remainder, and this is going to be using the greatest common divider for the steps and the total. So with this we need to actually use math.gcd of the steps and the total so far. So I need to import math at the top here. We don't need PyTest anymore, so we could just do that. Import math. This isn't t, this is the count. Cool. So if I just print out the total here, then we'll be able to see what roughly what this is doing. So we have part 1, let's do part 2. So we can see that this, we've got a passing test, firstly, which is great. So we then have 1 times the total amount of steps multiplied by the amount of steps for the first one. And then we're going to get the greatest common divisor between the steps and the total, and we're going to get the remainder of the division of those two. Yep, I think my maths is right. We're just going to keep doing that. So that's going to then just keep incrementing, and it then gives us that final amount there for the total, which is the lowest common multiplier for all of these different loops to work. So this was a fun one. This one was quite mathy. It was my first time that I had kind of gone through a lowest common multiplier since I left school, which, I don't know, nearly 20 years ago, something like that. So yeah, I can't. I don't even know how many years ago it was that I left school. Very long time. Before I went to college, before I went to uni, before I'd been out of uni, all of that stuff. Yeah, lowest common multiplier. Last time I used it was a very, very, very long time ago. So it's good to have this little refresher. It was interesting, this one, building up loops of, or building up the loop counts, so then we can get the lowest common multiplier rather than repeating the same thing so many times. This is how many times we would have to do the whole thing. So it's good that we didn't have to do it that many times. We could actually just use math to get to the solution in the end. So there we go. That was day 8, part 1 and part 2. Thanks again for putting up with me for half an hour. Yeah, have a great rest of your day and see you for part 9.